Again, you might recognize this or think you recognize this. It's very similar to what I did a few days ago, December 26th, I think it was. I'm not sure about the wisdom or foolishness of having it so similar. This does have a different equation that we're solving by kind of a recursive method. Recursive is a word you might want to learn. So you can read this pretty much. I don't want to spend a lot of time on it again. Go to the next page here. I guess it's worth mentioning here we have x minus 5. Yeah, you can have negatives like that. It's okay. Everybody understands what you mean. So the area of this thing, you multiply the length, x minus 5, times the width, x plus 2, and you get x squared. There's the x squared. Negative 3x, how do you get that? Well, you've got 5 negatives here. 2 of those will cancel out because these are positives. So there's your negative 3x. And then negative 10. And I could put negatives in on those ones, but it's fine like this. And here's the answers to these questions right there. Then, so we got the roots by factoring this in up here, put down the distributive tiles in order and factor it by getting the width and getting the length. But there's another way. Let's go on to see what that is. And it's not the quadratic equation either. Right here, I have that the roots of this are 4 and 1. I don't want that. Let me change here. I don't know why I got that up there. Let's go to minus 2 here. Right there in the 5. And I guess we got it. Okay, that's so we're doing x squared minus 3x minus 10. And having it set equal to 0. And while it's set equal to 0, we're developing this equation right here, solving for x. So this all depends on y being 0. This is kind of a recursive formula. And the roots we already know, I told you, are negative 2 and plus 5. Here's the curve for y equals negative 3x minus 10 equals y. Okay, let's go to the next page. And it kind of says that again. Read this. I just said it. Okay. So go to the next page. Pause that and look at it as long as you need to. And we arrived at this recursive formula. If we put in negative 2, we should get negative 2. Well, you do. X equals negative 2. Put in 5, should get 5. There it is. X at y, because negative 2 and 5 are the roots, and that's all this works for. Let's go to the next page. I mean, what if we put in a number like 1? I mean, you can put in any number you want here. Negative 2, only negative 2 and 5 will give negative 2 and 5. Well, let's put in 1, so the next page here. And negative 1 gives, 1 gives 13. Put a 1 here, get 13. Okay, pretty easy, and do that in your head. And then we're going to put 13 into both of these places here. See what we get. But do read all this. There we have, again, the 1 gives the 13. Here we have the 13. We put that in, it gives 3.769 something. We put that in, 3.769 right in these two places. Then we get 5.65, put that in those two places. We just keep going on like that. And as we do, as we keep putting it back in there, 5 seems to be what it's converging on, this mathematical environment. And we keep when we keep putting this number back in there, when we generate an answer, we put it right back into the same mathematical environment here. And we can see that it's evolving closer and closer and closer to that perfect root of 5. So we go down here. There it is. There's the 5. Okay, let's go look at a summary. So we tried to solve this by dividing through by x. You need to know x to find x. How does that work? Well, you can start out with a guess and then get an answer from using those guesses, and it should be closer to the perfect root. Here I put in 1, and we got 13. It didn't seem to get closer to it. But as we go down through here, now, yeah, it's getting closer to the 5, as you can see. Now I stopped putting all the formula in here, just the answers over here. So as we look down through, getting closer and closer and closer and closer and closer, 5 finally becomes 5. Now we could even enter a mistake in this evolution process. You know, maybe an asteroid would hit the Earth or something and cause this to happen. Let's see what happens now. Go down. Well, still coming to 5 there. Or maybe we could put in the exact number, like negative, what was it, 2? Yeah, look at that, negative 2. If you just put the perfect answer in there, just create it somehow, then there it is. It's always going to, or they create an exact answer right there in that time of the evolution. Bam, there's 5, always a 5. Okay? And you can read this pretty much the same as what I said on December 26th. And finally, we have the credits here. So you can look at those, and it's not time to go through them all.